Hello, in this video we're going to talk about compound interest. So if you invest 3,000 in the bank account, paying 3% interest compound quarterly, how will the account be worth it in 10 years? In the previous videos, we talked about exponential growth, which is fx equals to a times 1 plus r to the t power, where t is the time, r is the rate, the growth rate, and then a is the initial value. So why we can apply this function to a compound interest one? Because when we're talking about paying the interest rate, this rate is a annual interest rate. However, the way that this compound is compound quarterly, so that means you see there's something that disconnected here. One is given you a interest rate is based on yearly, and then the other way is they compound quarterly. So how can we make these works? Well, then we introduce a new function which is really similar to this one. So we need to divide it by a k, and for the time we times k. Why is that? So what is k? K is the compound period, or the number of compounding period in a year, or the compound frequencies. Or the number of the compounding period in 1 year. So now let's take a look. Quarterly, so how many times you compound this, how frequently you compound it within a year. So you totally have 4 quarters. So that means in this specific case, k is equals to 4. Okay, so everything else is the same meaning. A is the initial value, r is the annual interest rate, and t is the time. So we plug in everything. We have fx equals to a. You initially have 3,000 in your account, and then your interest rate is 3%. You compound 4 times a year, and then t is 10 to the k, which is you compound 10 years. Totally you compounding what, 14 times over this 10-year period. So that's how that works. So now everything is computed by quarterly, right? Because once you use the annual rate divided by 4, that gives you the quarterly interest rate. So the quarterly interest rate is what? 3 divided by 4. 3% divided by 4. And then you do how many quarters you totally compounding? 10 times 4. So that's why how does this function works. So now I'm going to show you how to compute that on a Google calculator. So on Google calculator, we reset everything. So now we have what? 3,000 multiply parentheses 1 plus 3%. We need to convert this to a decimal. 3% divided by 4 to what power? To 4 times 10, which is 40. So this gives you, hey, after 10 years period, if you invest 3,000 in that bank account, you are getting $4,045.50. We round it to the 2 decimal places because the bank, they can't give you something less than a cent. Okay, so that's how we work for compound interest. So now, how can we determine if they tell you that, hey, I want to compound sorry. If the way the investment bank account compound yearly, so that our K is equal to 1, but if they tell you that, hey, I want this to compound daily, K is equal to what? Then we let K equals to 365, right? Because you totally compound 365 times within a year. And then if they tell you that, hey, this account is going to compound monthly, so you think about monthly, totally there will be 12 months in a year, so that means our K is equal to 12 monthly. And then if they tell you that, hey, this is going to compound semi-annually, so our K is equal to what? Semi-annually means they compound every 6 months. In a year, you will have 2 6 months, so that's why K is equal to 2. So you just play around something like that. Let me give an examples. So here, a 429 plan is a college saving plan in which a relative can invest money to pay for child's later college tuition, and the account grows tax-free. If Lily wants to set up a 529 account for her new granddaughter and wants the account to grow to 40,000 over 18 years, and she believes the account will earn 6% compound semi-annually, which is twice a year, how much will Lily need to invest in the account now? So when you look at the question, first of all, you need to notice, okay, what do they want to ask? They want to ask how much will Nini need to invest at the account now. That means that equivalent to ask you what is the initial amount that does Nini need in order to grow to 14,000 after 18 years. Okay, so we have the formula fx equals to a times 1 plus r over k to the t to the k. So a is the initial value. That's unknown, right? But what do we know? We know that the final amount that we want is 40,000. So that means fx equals to 14,000. And then the rate is going to be 6%. So which means this is 0.66. And how often do they compound? This investment account compound semi-annually. That means K equals to 2. And then the time is over 18 years. So T is equal to 18 times 2. So that's the formula, and we want to solve for A. So how do we solve this? Well, first of all, we can calculate everything inside the parentheses first. So I have 1 plus 0, 0.3, 18 times 2, which is to the 36th power. And then this is multiplication, right? To undo a multiplication, we can divide it this whole thing. Or you can calculate these whole things first. So now let's use a Google calculator. So here's the Google calculator. We want to calculate that 1 plus 0.03 to the 36 power equals to what? 2.898. 2.898. So we can write down, hey, 14,000 equals to A times 2.898. We can round to the 3 decimal places right now, and then we can use 14,000 to divide everything that we have, which is ANS, which is the answer that gives you a really accurate answer, which is 13,801. Because after this, we want to divide it by 2.898 on both sides, so we will have our A, which is 13 $1,801.13. That's how much money that does Nini need to invest right now if she wants the account grow to 14,000 over 18 years. Okay, so the next part I want to talk about is this is compound interesting. We know that they compound frequently, right? Sometimes daily, sometimes monthly, sometimes semi-annually. What if something like radioactive reaction? They don't have the frequencies, right? They don't have the frequency like daily, monthly, and semi-annually. They happen every single minute, every single second. So this kind of growth, we call it continuous growth. For continuous growth, we use a formula. Oh, sorry, I spelled it wrong. Fx equals to a times e to the x. Well, e is the natural number. It's really similar, it's just a constant. It's similar to pi equals to 3.14. E is equals to 2.71. Let's check it. I don't really remember the exact number, but every calculator will have that. Did you see that E in here? So let's say E is equals to 2.18281, which is 2.72. So that's our E. Just think about E as a constant number, similar to our pi. But anyway, other than that, A still is the initial amount, initial quantity, and X, which is on the exponential, sometimes they use T, is the time, oh sorry, rate. This is the rate. Also X is the time, but I think we're more comfortable with using T. But anyway, you sometimes use T, sometimes use X, they both work. And then our E is just a constant, which is equals to 2.72. And the Fx still the same, which is the final amount that we want to attend, or we want to find out. So this type of question usually is used to a chemical reaction, such as if I tell you that, hey, this is a isotope atoms, random 222 decays at a continuous rate. Of 17.3% per day. How much will 100 grams of random 222, okay, I spelled this wrong, sorry, I'm bad at spelling, should be random 222 decay to in 3 days. So remember that in the previous videos, I think it's the first video that we talked about exponential function, we have something similar to that. By that time, we're using the formula is fx equals to a times 1 plus r to the t power, which is the t is the time on the top, and then r is the rate. But now, since we learned the continuous growth, this is more accurate, will give you more accurate answer, because since the reaction is continuous happening, right? It's non-stop. So also they give you this, the keyword continuous rate. So that means we know that, hey, now we need to use our new formula. fs equals to a times e to the r to the x or to the t, whatever you're comfortable. Just remember on the power is the rate times the times. Okay, so now I have what? A equals to 100 because they give you the height. At beginning it was 100 milligram, and the E, which is 2.72, or you don't even need to do anything, it's just embedding into the Google calculator or any other calculator. And then R is the rate, is 7.3. Since it's decay, another keyword decay, so we want it to be negative. We convert this to a decimal, which is 0.173. And then the time is 3 days. Okay, the rest, after you pick up the function, the next thing to do is just plug everything in to the formula. I have fx equals to 100 times e to the r negative 1.73 times 3. Okay, now let's use a Google calculator to do that. So I have 100 multiply our e to what power? Negative 0.0173 multiply 3. Okay, so that means after 3 days, 100 milligram of random 222 remains to what? 59.51 milligram. So, okay, let me recap everything that we learned so far. So we have learned an exponential function. The most basic one is fx equals to a times 1 plus r to the t, or to x. You can use any number, but remember that on the exponential usually means the time. And then the other one is compound interest, which is a times 1 plus r over k to the t times k, where k is the compound frequencies. If you compound quarterly, that means k equals to 4. If you compound daily, k equals to 365. And the last is the continuous decay or the continuous growth, which is a times e to the r to the t, whereas a is the initial value, e equals to just a constant 2.72, r is the rate. If it's decay, it's going to be a negative. If it's a growth, it's going to be a positive. T is the time. Okay, so that's it for today's video. Let me know if you have any other questions.